the words are very hard to read. It's not even identifiable. So take care of all these things. Also take care of the landscape and the portrait mode whenever you upload your assignments or whether it be the test papers, solutions of the test paper. Okay, now. So take care of these things. It will be convenient for the examiner also to check the paper, and they will also give you more marks when they see that the paper is well organized and well structured. Got this?
Okay, sir.
Okay. So today we are going to discuss this chapter, force and pressure. Just let me update what we have done so far in the batch, what we have done so far. All right now. So it is important that you should know what we have done and what is left to be done so far. Okay, guys. So far in the chapter, okay, let's see who knows like what chapter we have done. Yes, Aisha, what do you think? Which chapters have been done so far? Mm-hmm. Yes, Ibrahim, what chapters we have done so far in the batch?
Crop production and management, microorganisms, friend and foe, conservation of animals and plants, reproduction in animals, electric current,
chemical effects of electric current.
Yes.
Okay, very good. So far now we have done the chapter crop production and management. So this chapter has been done. Next, we have completed the chapter microorganisms. Okay. Microorganisms, friends and foe, it has been done. Coal and petroleum, it has been done. Next, we have completed combustion and flame, that has been done.
It's a pollution of air and water. It's finished.
No, not in this class. It has been done in the other batch. Okay, no?
Oh, okay.
Combustion and flame. Then you have conservation of plants and animals, that has been done. Then reproduction in animals, that also has been done. Okay. Then after that, we did the chapter chemical effects of electric current. Okay. Chemical effect of electric current. Now the chapters which we are about to do, which has been left to discuss, are as follows. We have the chapter, let me write left, and the one that has been done. The chapter that is left to be discussed is reaching age of adolescence. Reaching age of adolescence, that is left. Then we have force and pressure. Then friction, sound, some natural phenomena, and then the last chapter is light. Okay. So almost more than 50% of the syllabus has been done, and this has been done as per the syllabus of you guys. Okay, now, but for Vaiga, some of the chapters are left to be discussed. Okay.
Yes, sir.
Okay, and from this section, Vaiga, you are having this chapter force and pressure.
Yeah.
Okay, that is there. Friction is also there.
Yes, sir.
These two chapters are there for you. Force and pressure, and then friction, if I'm not wrong. All right, and for you, the chapters chemical effect of electric current, that has been done. Crop production, you were present there also, that has been done. And what else? Conservation of plants. I think you were absent back then while this was going on.
But then I studied it, so it's okay, sir.
Okay, good. So for you, extra class will be scheduled for the chapter synthetic fibers. Okay, now others no need to worry about this since it has been removed from the updated syllabus. Only some of the school are following this. Okay, so synthetic fiber, a class will be scheduled for you. And do let me know about the other chapters like pollution of air and water and other chapters for which you'd like to have a class. Okay.
But I think, sir, pollution of air and water, I was there.
Yes, it is.
I think pollution of air and water, I was there for that chapter.
You were there, no?
Yes, sir.
Okay, you were in the other class. You? Okay, you were there in the backup class.
Yes, I think so.
Okay, okay. Anyways, so without wasting our time into any other thing, let's go into this chapter. All right. So
Okay, sir.
today we will be starting the chapter force and pressure. Just let me clean these things now. Just give me 1 minute, guys. Meanwhile, you guys can answer some questions to me. Okay. Okay. You guys tell me, what do you guys understand by force? Huh? What do you guys think? Like, what is force?
It's a push or pull.
Hmm? Okay. Push or pull, and what are some of the examples of forces that we can see in our daily life? Yes. Like when you lift an apple from a fruit basket, there you're doing force. You're pulling it.
Yes, sir. Muscular force.
Okay, muscular force. When you lift some heavy weight, so you're
Yes.
applying muscular force. Okay, and what else?
Gravitational force from the earth.
Mm-hmm. Good. And so, like what you're saying, like the actions that you guys have mentioned, like whether we pull some fruit from a fruit basket, or when we lift some weight in the gym, so their interaction is taking place between the two
Yes,
body.
sir.
So that type of interaction is it a contactless interaction, or a contact is taking place there?
Contact force.
Right now, so physical contact is taking there, right? Okay, but what about a magnetic force? How does a magnet attract another magnet or other magnetic objects? Yes, there isn't any contact there,
No,
but
sir, it's not.
still force takes place between two magnetic objects. Huh?
Yes, sir.
Okay, what about two charged objects, or a charged and uncharged body? What happens there? Yes, guys, just wait for a minute. There's someone on the door. I'll be back in a minute. Okay.
Okay, sir.
Sorry for the interruption. Is there some background noise from my side?
No, sir.
Okay, okay. All right. So talking about force, these are some of the different actions here. Say, like we are pushing this object here. On one side, we are pushing it. Here, you are pulling. You are also pushing this object over here. Or like here, we get to see that this is the pressure meter. What we get to see that in the chapter force and pressure, what we will learn in the case of force, that whenever you push something or whenever you pull something, whenever you are pushing something, like you are pushing this weight here, huh, or you pull something, so there that will be called as force. And force can occur in two manner. The type of interaction that will be taking place between the body, where here like they are directly in a physical contact here. So that is the contact force. The examples are like frictional force, spring force, muscular force, where the two body or more than two body are in direct physical contact, and that's how force comes into action, when two or more than two body will be in contact with each other. So that is the case of contact force. But in some of the examples where even the body are not in contact with each other, but still force takes place between them. got this. Like we have the example of this magnetic force, how a magnet will be attracting these pins, how this apple is falling from the plant, or how these tiny pieces of plastics or polythenes get attracted to a balloon here. So this is because of electrostatic force. This is gravitational force. This is magnetic force. Getting it, guys? So talking about force, force is nothing but it's a push or pull that is applied to an object. That is what force is. A push or pull applied on an object, that is called as force. Furthermore, force will always have some magnitude and it will always be acting in a direction. Meaning that this force which we are doing here, like for example, this muscular force. So with some energy, with some force, we are going to pull it. We are pushing it into air. So we must have spent some energy in it. We must have to apply some force on this. Let us say we have applied 50 Newton of force on pushing this weight into the air, like this here, on lifting this. Also, we are applying a force in a particular direction here. Or take the case of this here. Like, take the case of this one over here. Like you are pushing this ball in a given direction here. You might have pushed it with some force. Let us say the magnitude of the force would be 5 Newton. And it moved in this direction of, let's say, northeast direction. In the northeast direction, it moved. Northeast direction, it moved. So what we get to see here, that whenever force comes into action, it will have some magnitude and it will be acting in a direction only, in a direction also. So thereby, force is called as a vector quantity. Force is called as a vector quantity. Getting it, guys? Force is called as a vector quantity because it has both magnitude and direction. Getting it? It has magnitude and a direction in which acts. Say magnitude could be, for example, 10 Newton, 20 Newton, 100 Newton. Direction could be left, it could be right, north, south, east, west. So a quantity that has both magnitude and direction, that is called as a vector quantity. Getting into all of you. Is this thing clear to everyone? Please let me know. I suppose I'm audible to all of you.
Yes, sir, but that's not clear.
Okay. Let me clarify it. See, you have two kind of quantity. Let us say you have, take the example of mass of a given object. Let us say 1 kilogram, let us say 100 kilogram. On the other hand, right now we have learned about this force here. So when we get to see this magnitude of mass like 1 kilogram, and magnitude here basically means value. Okay, no? So the value of a given of object, its mass can be 1 kilogram, 100 kilogram. So you only get to know about its magnitude. Do you get any idea about its direction? Like, do we ever get to say like 1 kilogram in the north direction? Do we say that?
No,
1
sir.
kilogram in the left or the right direction? Yes, Aisha, Weiger, and Ibrahim.
No, sir.
But in the case of force, what we see that, see, you have a wooden block here and you are applying a force on it on the right direction. You are pushing it with a force of 10 Newton. So we have the magnitude and the direction both. Yes or no?
Yes, sir.
Aisha, what about you? And Ibrahim? You guys not getting it? So thereby, a quantity that has both magnitude, a quantity that has both magnitude and the direction, they are called as vector quantity. Just let me take one empty slide here. So quantity is of two types. One that only has magnitude, that is called as scalar quantity. Another one is called as vector quantity. So scalar quantity only has magnitude. While vector quantity has both magnitude and direction. Has both magnitude and direction. We have the example of scalar quantity as mass, like 1 kilogram, 5 kilogram, where only the value of the given substance is there. Direction is not specified here. But in the case of vector quantity, we have the example of, let us say, like the case of force, we have this. So we have 10 Newton in the right direction. Let us say we are applying a force of 10 Newton in the right direction. Some other examples are velocity. Velocity is basically when we talk about speed and the direction also, then that is velocity. Let us say I am driving the car at a speed of 50 kilometer per hour in north direction. So I think it should be clear to everyone now.
Yes, sir.
Good then. So
So
far what,
can you just show the previous I'm writing?
just let me clean this one by the way. Yeah. Done?
Yes, sir.
Okay. So talking about force, what we have learned so far, it's a push or pull that is applied on an object. That is what force is. Force can change the state of an object from rest to motion or vice versa, meaning that this football was in a state of motion. Now this person has brought it in a state of rest. Or this ball, let's say it was in a state of rest. Now it has been brought in a state of motion. Here it has been brought in a state, brought from a state of motion to a rest. So we can either bring an object from rest to motion or from motion to rest. Further, to let force come into play, two or more objects must interact with each other. And that interaction can either be like where the two objects will be physically contacted, while it could be from a distance also. So on that basis, on the basis of interaction, you have two type of force, one that is contact force, another one that is non-contact force. Hope it should be clear. Getting it, guys, everyone?
Yes,
Okay.
sir.
Good. Then, like, do magnets also exert a push or pull? Of course they do. Huh? Like here, the unlike poles, they attract. The like poles, they will be repelling each other. That is the case here. Okay. Now let's do this. Let's complete this table. It's from the NCERT. So you have different actions mentioned here. You have to mention whether there is a pushing or pulling, or whether lifting is being done, or whether throwing or shutting is being done. Like what kind of action is being done here. And those actions can be grouped as either push or pull. So opening or shutting of a door. What actions are involved?
Pushing and pulling.
Pushing, pulling. So action can be grouped as both push and
Pulling.
pulling. Good. Okay. Okay, next one, Aisha, you tell me this one, Ibrahim, this one, Vaiga.
Pushing, pulling, and
Draw a
lifting.
bucket of water from a well. So we are pulling, we are lifting. We are not pushing anything here, I think, right? So
Yes, sir.
pulling is taking place here. Action can be classified as pulling because lifting is basically pulling. Yes, Ibrahim. Yes. Okay, Vaiga, you answer the fifth one then.
Okay, so like a cricket ball hit by a batsman, it's either flying or throwing.
A cricket ball hit by a batsman. So out of the given option, it is
Flying.
flying. It's not mentioned here. It's pushing now, like you are pushing the ball with the help of the bat now, like
Oh, okay, sir.
you're pushing it. So pushing is being done here. Okay. And what about pulling? No, pulling is not happening here, right? Or can we see like throwing? Kind of with the help of bat, we are throwing it into air,
Yes, sir.
right? So we can say that. So pulling is happening here only. I mean to say pushing, not pulling.
Okay.
Okay, last one, sixth one, Aisha. Moving a loaded cart.
Pushing and pulling.
Pushing and pulling both. Right now? Okay, very good.
Yes.
Opening a drawer.
Pulling.
Pulling it. Good. Okay. Now let us understand about the characteristics of force. So talking about the characteristics of force, the first thing is that force, when it is applied on a body, it might bring the body into motion. Let us say what we know, that the body first of all will try to resist its movement because of friction. The body will also apply a force in the opposite direction, like these two boys are applying the force in the left direction, but we know that the surfaces of objects are irregular now. Like the surface would be like this, it would be irregular like this. Getting it, guys? So when two irregular surfaces are placed on one or one over another, so they get interlocked into one another and they resist the movement. Like I'm trying to push this, but due to the irregularities, it is also applying a force on the other direction. That is called as frictional force.
Yes.
But when we overcome this force of friction, now when we apply too much of force, then the object will come into movement. The first characteristics of the force is that it can bring an object in motion or vice versa. If it is in a state of motion, it can then bring it in a state of rest. That is one thing. Okay. Also, force will always has a direction in which it is
So can
applied.
you give a sign?
Yeah, sure.
Okay, sir.
Also, in this case, like what we get to see, that there will be a direction, like since we know that force is a vector quantity. Okay. Also here, what we are getting to see, that the two force are acting on this object on the same direction, like two force, like this person, let's say this person would be applying a force of 10 Newton, this person would be applying a force of 15 Newton on it. So the net resultant force that is applied on this will be the sum of the two individual forces, that is 10 plus 15 Newton. And the object will be moving in this direction, in the left direction, with a force of 25 Newton. Got this, everyone? So this is the case of a unbalanced force. Unbalanced force. Why? Because on the other side, there isn't any force that is acting on it to counter this 25 Newton force. I mean to say that, say if there was this case where two boys are applying force of equal magnitude from the opposite sides, the body will be not moving, and it's a balanced force. Getting it,
Yes,
guys?
sir.
But in this case, what we're getting to see, that this is the case of an unbalanced force, where, like, say that two forces are applied from one of the side. So the object, the net force on this body will be the resultant of the sum of the two individual forces here. So here, in the case of unbalanced force, the resultant force, or basically the total force is the sum of two or more than two forces. So when two forces are acting in the same direction, the net sum will be their resultant. Okay, you guys answer this question. Say you have this wooden block here. I'm applying a force of 10 Newton and 25 Newton. What
Okay,
will
sir.
be the resultant force? What is the resultant force here?
So
35.
35. So 35.
35, that is correct. So that will be 10 plus 25 Newton, that will be equal to 35 Newton. Hope you guys have understood this so much so far. Okay. Furthermore, we have also learned that it can alter when the direction of the magnitude of the force changes. Like the effect of force may alter when the direction of the magnitude of the force is changed. What does it mean? The effect of a force, it may alter when the direction of magnitude of the force is changed. Like earlier, the body was moving in this direction. It was moving in this direction. But if the direction of the force changes, now the body will be moving in the other direction. That is what it simply says. Okay. So far we have learned about some of the characteristics of force. Like it can bring an object in a state of motion, or it can bring it in a state of rest from motion. In the case of unbalanced force, the net sum of the force will be the net force acting on the body will be the sum of the individual force acting on it. And in the case of unbalanced force, what we see that what we conclude from this, that the object will be moving here. Whenever there's a unbalanced force acting on a body, as a result of that, objects move. Object will move in this case. All right. Now moving on, we have learned object force as a direction. We have learned this. Also, we have learned that the effect of more than one force that will be applied on an object will be found out, will be evaluated by summing up all the force on it. Now, what if the two forces are acting on the opposite direction? If two forces are acting on the opposite direction, so that is the case of unbalanced force. That is the case of unbalanced force. So if two forces are acting upon each other, having, it should be actually balanced, it turns out that. So if two forces are acting upon each other having equal magnitude, then the net force here refers to total force. So the net force on the object will be 0. On the object will be 0. So it will be calculated in this manner. Net force will be F1 minus F2 here. That is 10 minus 10 Newton. That is simply 0. So in the case of balanced force, the overall force acting on the given object is always 0. So will the object move? It will not move. So object does not move. Object does not move. I hope it should be clear. Yes, Aisha, Ibrahim, and Vaika.
Yes, sir, it's clear.
Good. We can take some examples of these unbalanced force here. We are able to carry out, in fact, everything that you get to see moving, it is because of unbalanced force. If it wasn't for unbalanced force, nothing would be moving. So here the vehicle will be moving in this direction because a net force of like 8 Newton is acting in this one, here 3. So the difference is 5. So the net force will be acting in this direction with magnitude 5 Newton. So
can I just use the restroom?
Yes, this one.
No, sir, can I just use the restroom?
Okay. So that is the thing. How a rocket will be launched into the space because of unbalanced force. Getting it now? So these are some of the examples of unbalanced force because of which object will come into motion. But in the case of balanced force, the object does not comes in motion. It will stay in the position of rest. Now, furthermore, in later classes, we'll be learning about the concept of like how you can find the force if mass and acceleration of the body is given. Okay. So you can calculate the force in this manner. Also, so far we have learned about one more thing, that the SI unit of force is Newton. SI unit of force is Newton. And in short, this is represented by the capital letter N. Getting it, guys? Okay, you guys answer this simple question to me. Who was Newton? Yes.
One
What was his
about gravity.
Okay, good. What were his other works? What is the Newton famous for? He gave laws of gravity and laws of motion also, right now, and those laws are still studied till this day. Getting it now. Also, he has published some very popular books. He was a professor of mathematics also. Okay, no, in the Cambridge, he was a professor of mathematics as well, and he was the person alive in the, if I'm not wrong, in the 17th century. Got this. So he gave laws of um, um, gravity and laws of motion. In fact, you would be learning about 3 laws of motion in the 9th standard. Okay, so that is the thing. Anyways, but what is Newton like? What does this Newton basically here mean? I'm not talking about the name of the Isaac Newton. By definition, what does it mean? Let us understand that thing. Okay. So what we know that this is the SI unit of force, but how is SI unit of something calculated? It must be something standard, because SI unit is accepted everywhere now. SI unit of mass is kilogram. So no matter where you are in USA, where you are in India, whether you are in Egypt, everywhere 1 kilogram will be same, right now. So this Newton, it must be something standard. So talking about the Newton, so Newton is the, or basically it is equal, all if you try to understand this, this is very important. Newton is equal to the force that will be required to accelerate an object of mass 1 kilogram at 1 meter per second square, per square second, per meter square second, 1 meter per second square. So this is the definition of Newton. Say that you are given with an object of 1 kilogram mass, and if I were to ask you to accelerate this object at a speed of 1 meter per second square, so whatever amount of energy you will be required, whatever amount of force will be required, that will be called as 1 Newton. So it's the amount of force that is needed to accelerate a 1 kilogram, a body of 1 kilogram mass by 1 meter per second square. Are you guys able to understand this thing? What I'm saying? Ibrahim, Aisha, and Vaika, you guys getting it? What I'm trying to say?
Yes,
You
sir.
you are provided with an object of 1 kilogram, and I am asking you to accelerate this object with a speed of with a acceleration of 1 meter per second square. So the amount of force that you will have to apply on this, the amount of energy that you will have to apply on it, that will be called as 1 Newton. That will be called as Newton. And this is the SI unit used for the measurement of force. Hope it should be clear. Some of the other characteristics of forces are as follows. It can change the state of motion of an object. In fact, we have learned about this. Like this truck, toy truck is in a state of motion, in a state of, I mean to say, rest. By moving it, by pushing it, we can bring it in a state of motion now. Or let's say if it was moving with some speed, after pushing it, its speed will increase. Okay. Or we can decrease its speed also, right? Furthermore, we know that an object will be said to be in motion if it is moving by a certain speed in a given direction. That's when an object is said to be in a state of motion. When it is changing its place in a given, it's moving in a given particular direction here. If it is at rest, it means that it is not changing its position with respect to an observing point. Meaning that, let us say that there is a pole over here and there is this car. So what I see that after 5 minutes, the position of the car has changed here. So time has passed here. Time has passed, and this pole was taken as a reference point. So with respect to this pole, the car has changed its position. Earlier, it was left of the pole. Now it is on the right direction of the pole. So an object will be said to be in a state of motion when it will be changing its position with respect to time. Like it took 5 minutes to move from here to here, time was consumed, and it changed its position with respect to this stationary object. Like pole is not walk from here to here, no, it's a stationary object. So it can be called as an observing point or a stationary point. You guys getting it what I'm trying to say?
Yes.
Okay. But let us say that time has passed, 5 minutes has passed, but still the car remains at the same position. Then it will be said to be in a state of rest right now because it is not changing its position with respect to this observation point. Is that thing clear? So earlier, to bring this car from to change the position of the car from here to here, a force was required. Force was required. Hope these basic things are clear. In fact, not only this, what we know that an object, the force when applied on an object, it can change its speed, bring it to rest, or even change the direction of its motion. These things we have learned several times. It may bring a combination of these effects at a same time. Like for example, when you are driving on a straight road and say that there's a sudden curve in the road. So at that time, two changes will happen in the car. What are those? You guys tell me. When a car is driving on this road and you have to take a sudden turn, so two things will be changing here. First
Car
thing
will
is
slow down.
car will slow down, so its speed changes and
Its direction will change.
direction. Very good. So due to action of force, the speed is changing and the direction is also changing of the given body. So at the same time, two effects can be observed. In fact, more than two effects can also be observed here. Got this now? So force can bring a combination of the effect at any given time. So all the things can be seen at one single time. Okay. That is one thing. Okay. Furthermore, force brings about change in the shape of a given object also. Like you can stretch a rubber band, you can press this sponge, you squeeze a spring, but after releasing it from force, it restores back to its original shape. So force can change the shape of an object also. That is also one of the characteristics of force. Getting it? So that is the thing. Okay. Then type of force in the beginning, as we were learning about interaction. So based on the like for force to come into action, the object have to interact with each other. That could be a contactless interaction, or that could be an interaction where they will be physically touching each other. Okay. So these kind of forces are applied when only when two or more objects will be coming in physical contact with each other. We have example of muscular force and frictional force. While in non-contact force, the objects does not necessarily need to be in contact with each other. Okay. Examples are magnetic force, gravitational, and electrostatic force. All these actions that you see here, all of them requires. All of these are examples of contact forces, right? So, what kind of contact forces are required here? You can see like muscular and frictional force both is taking place here. Like while you are pushing this piece of rock, so your frictional force also comes into action here, and the muscular force applied by our muscles that also comes into action in all these actions here. Here also, what kind of force is coming into action in this case? Yes.
Contact force.
It's a contact force. Specifically, specifically it's
Muscular force.
muscular force. Okay. But at the same time, we see that frictional force will also be coming here, like in the between the here. Okay,
Yes,
now
sir.
between the ground and the
Yes, sir.
soles of the shoes. That is one thing. So talking about the frictional force, read this paragraph. Aisha, you read this paragraph.
Frictional force is the force generated by two surfaces that contact and slide against each other. A few factors affecting the frictional force. These forces are mainly affected by the surface texture and the amount of force impelling them together.
Impelling them together being that pushing them together, being applied on them. So frictional force, basically it is the force that is exerted by the surface over an object here, okay, between the surface of two bodies. So whenever one object will be moved over another object, so thereby frictional force come into action, okay. And there are different characteristics of these frictional force, like how much of friction will occur, what are the types of friction, getting it, and what will happen when a frictional force comes into action. So the first thing here is that the force of friction will always act in the opposite direction of the movement of the object, or also we can say that it will always act in the direction opposite to the direction of applied force. Like I am applying a force in the right direction, but the friction will occur in the left direction, getting it.
Yes, sir.
So very first property is that it always acts in the opposite direction to the applied force. Or let us say that if this object starts to move, then also friction will not, it's not like friction will stop here, then also friction will be occurring here, getting it now. Even if the object is moving, frictional force will be acting, but at that time also it will be acting in the opposite direction. So it always acts in the opposite direction to the applied force, or to the moving body. Got this? Okay. Also, this will lead to generation of heat also. So it leads to heat generation as well. It leads to heat generation, and as a result of that, what happens that the object will go through wear and tear. When heat is generated, the object will go through wear and tear. It will be damaged. That is one thing. It leads to wear and tear of the surface of the objects that will be coming in contact with each other. For example, the sole of the shoes, often it will be getting worn out due to friction that acts between them and the ground on which we walk. Got this, guys? Furthermore, the factors upon which the force of friction will depend, meaning that factors that determines magnitude of force, like how much of frictional force will be coming into action. Can you guys think of it? See, let us say that right now I'm applying a force of 10 Newton on this. So some frictional force will be applied here. Friction will also apply some force here. Getting it? But let us say I increase the force from 10 Newton to, let us say, 50 Newton. So the opposite frictional force, its magnitude will also be more here. Getting it, guys? So the very first thing that determines the magnitude of friction is the magnitude of applied force. Got this, Vaiga, Aisha, and everyone?
Yes, sir.
Magnitude of applied force. So it's like I am applying a force of 10 Newton on this. So this is also right now applying a force of 10 Newton on me. But if I were to apply a force of 50 Newton, so the frictional force also applies a force with 50 Newton. Frictional force. That's the case. Now, let us say if I were to increase the surface area, let us say if I were to have an object that has more surface area. So now area in contact is more. Now the area in contact is more here now, like this one is now more. Getting it now? So then also the friction will increase. So frictional force will depend upon area of contact between the body as well. Is that thing clear?
Yes, sir.
Okay, how can we reduce the friction then? how is it that we can reduce friction? Yeah, it's a simple question. Yes, anyone?
So can you repeat the question?
How can we reduce friction?
By reducing area.
By smoothing the surface, you're saying. And
So how can we increase or decrease friction?
no, I'm right now I'm only asking about decreasing the friction.
Like by changing the direction?
No, that's not the case now. Like by smoothing the surface, if the we know that the friction comes into action because the surfaces of objects are irregular. But what if we were to smooth it and make it like this? The friction will be reduced now. What happens? These irregularities, they kind of get interlocked into each other. Like just like how you can interlock your fingers, so they get interlocked. So if I were to smoothen this, the friction will be reduced. Or by the use of lubricants, I can reduce the friction. That is the thing. Okay. The next class we'll be learning about the fluid friction, where we'll be learning about friction in air and friction in water. But as of now, you guys tell me, what is the SI unit of force?
Newton.
That is Newton. Okay. How do we express the strength of force? Do we express the strength of force by weight, by its mass, or by its magnitude?
Mass.
No. I shall complete the whole sentence. I just heard the half of what you said.
Magnitude.
Magnitude. Good. Getting it now? Okay.
Okay, sir.
Now the force between two charged bodies. Let us say this is a positively charged body, this is a negatively charged body. So they will be attracting each other. What will be that force called as?
Magnetic.
Oppositely charged body. I'm not talking about opposite poles
Okay,
here.
sir.
Yes, yes. Vaiga, Aisha, and Ibrahim. See, I have given this much of hint. No one can recall this? That is electrostatic force, okay? That is electrostatic force, okay?
Okay, sir.
Okay, do tell me that when two forces will be acting in the opposite direction, like this and this. So the resultant force, the net force acting on the body will be what? Like this is F1 and this is F2. Will it be the sum of the two force or will it be the difference of the two force? Let us say that F1 is 50 Newton. Let me give an example. And F2 is, let us say, 30 Newton. So what will be the resultant force? And notice that they are acting in the opposite direction. So it will be, yes, F1. Ibrahim?
So it will be
F1 minus F.
Yeah. What about others? What were you saying, Vaika?
so like it will minus.
Exactly. Aisha, you getting it now? Like that will be 50 Newton minus 30 Newton. That will
Yes,
be
sir.
20 Newton. Okay. Okay, so that's it for today. Others can leave. Vaika, you will be staying for a few minutes. Like you have a discussion at this time for the chapter crop production and conservation of plants and animals. Okay.
Okay, sir.
Uh-huh. Yes, bye. Okay, so from the chapter conservation of plants and animals and crop production. In conservation, you were absent, right, Vaika?
Yes, sir.
Uh-huh. So do tell me if you have any doubts from those chapters. Do you think like you need some revision class for those chapters?
Which chapter?
From the chapter crop production and management and from the chapter this chapter conservation of plants and animals.
So conservation plants and animals, I actually studied this.
Mhm.
And crop protection and management, I was already there in the class, so it's okay.
It's okay. Okay. In exam you have done well. Okay, now your performance has been good.
Thank you, sir.
Very good. Okay, and if you need if there's any topic in this which you would like to revisit, do let me know.
Okay, sir.
Okay, I will be asking a few questions. Okay, do tell me, what do you mean by desertification?
So what?
What is desertification? What is desertification? And one more question, do tell me, when was Project Tiger launched? Tell me its launched year, what is its objective, and give one example of a wildlife sanctuary.
Okay, so the Project Tiger was launched in like 1973.
Exactly on 1 April 1973. Okay.
Yes, sir. And it was to check the population of tigers in India and help to conserve the species.
Good. Very good. So its aim has to be in protect and conserve the tiger in India.
Yes, sir.
Good. And
Sir, and what is the question of wildlife sanctuaries?
give one example.
Okay, sir. So, like for example, like Bharatpur Bird Sanctuary in Rajasthan.
Very good. Bharatpur, and we have one such example. Very good. Give one example of national park also. You have?
So, Desert National Park in again Rajasthan.
Okay. Or you have like some of the common ones are like Jim Corbett National Park in Uttarakhand.
Yes, sir.
And in fact, Project Tiger was started from the Jim Corbett National Park. Okay.
Yes, sir.
You have some others like Kaziranga National Park in Assam. Okay. Explain desertification. Like, what is desertification?
So, desertification, I didn't get that one.
Okay. See, desertification, like when there will be no rainfall in a given area for a very prolonged period of time. So thereby, let's say first of all, we have done deforestation in a given area. So deforestation, because of that, there will be no evaporation of water. So the water cycle will be disturbed. So if there will be no or very less rainfall, so over the course of many years, from being a fertile land, from being a area covered with vegetation, it will convert to a barren land and will simply convert into desert. So
Okay.
conversion of a fertile